Hello again. We're going to be doing series parallel. Okay, so remember when we do series parallel, you're going to either end up with a parallel circuit or a series circuit. If the first resistor next to the battery is in parallel, the last circuit or the minimized circuit will be a parallel circuit. If the first circuit towards the battery is in series with it, then you're going to wind up with a series circuit at the end. We're going to do this one second and this one first. Okay, and we always work from the furthest point going in. So the first thing that I see is I see 4K in parallel with 2K. And remember, when we have to get them in parallel, we'd get the reciprocal. Unlike in series, we simply add them up. So we note everything. 4K in parallel with 2K. What else do we know about that? Well, our total has to be less than the smallest resistor, which is 2K. So let's put this in our calculator. 4K shift reciprocal plus 2K shift reciprocal equals shift reciprocal equals 1.333 k ohms. So 1.333 k ohms. I'm going to move this calculator here because I don't really like it there. So then we circle it. So basically, we didn't do anything with the 38 volts, so we're going to redraw the circuit. We didn't do anything with the 10K. We didn't do anything with the 2.5K or the 3.5K. So we draw everything that we didn't touch yet. But what we did do is we put these two in parallel, which makes them basically shrink. So that answer would go right here. So now you have 1.333 k ohms. Now what do we see? We see, well, I see 3 resistors in series. I cannot put this in series because it's not in series with these. These 3 are in series, but the answer would be in parallel with the 10K. Because there's a power source here, you cannot put this 10K ohm in series with the other 3 resistors. So how do we get our total in a series circuit? We simply add them up. So we would add 2.5K ohms plus 1.333 K ohms plus 3.5K ohms equals, when we just simply add them up, it's 7.333 K ohms. We have that, so we circle it. We redraw it for one last time. We have 38 volts. We have not done anything with the 10K ohm resistor yet, so we draw that. But what we did do is basically just put all 3 of these together. And so this answer would be in parallel with the 10K ohm resistor. So let's put that in parallel with it. 3K ohm. Do we have to go any smaller? No. We can get R total. We can get I total. We can get the current here and the current here, just like it's a regular parallel circuit. So what do we know about parallel circuits? Voltage is constant. So we have 38 volts here, and we have 38 volts here. So let's get these 2 currents by taking E divided by R to get this current, ER to get this current. Then we can get R total and I total to make sure that these 2 are correct. So, we can do 38 volts divided by 10K equals 3.8 milliamps. So 3.8 milliamps is the current there. Then we do 38 volts divided by 7.333 K equals 5.18 milliamps. So 5.18 milliamps. Okay, so we have the current coming here and here. To get R total, remember we have to do the reciprocal, and R total is going to be less than the smallest resistor, which is 7.33. So we do 10K shift reciprocal plus 7.333K shift reciprocal equals shift reciprocal one more time, and we get 4.231 K ohms. To get I total, it's simply 38 volts divided by the last answer, which is shift answer. So we have 8.98 milliamps. 8.98 milliamps. Great. So add this plus this. That has to be verified. Make sure that it adds up to this, and it does. Okay, so once this makes sense, we go to the first thing that we have circled, which is here. I'm talking about this resistor. This is the voltage across this resistor. This is the current through this resistor. How did we get this? Well, we did a series combination. So what's constant in a series circuit? Current. So this current goes back to these three resistors, which are right here. So you multiply 5.18 milliamps for these three resistors. This one, and this one. And those three voltages must add up to where it came from, which is this resistor. So they have to add up to 38 volts. So we have to do those calculations, and I'm going to stick this in my memory. So 5.18 milli. Okay, I want that number saved in alpha Z. Okay, alpha Z times 2.5. Okay, could you just type them out? Yes, you can. So that's 12.95 volts. Alpha Z times 1.333 K equals 6.90 volts. Last but not least, alpha Z times 3.5 K is 18.13 volts. You need to verify that this voltage, and this voltage add up to where it came from, which is this guy. Once it does, last but not least, you go to the last thing you have circled and you say, how did I get this? Well, I did the parallel combination to get this resistor, which is right here. This is the voltage across, this is the current through this resistor. So what's constant in a parallel circuit? Voltage. So this voltage goes back here, 6.90 volts here, and 6.90 volts here. We're almost done. Now we have to get this current plus this current, and these two currents have to add up to where it came from, which is this guy. Voltage across, current through. So they have to add up to 5.18 milliamps. So I'm going to do 6.90 volts divided by 4K. And I got 1.73 milliamps. So 1.73 milliamps here. And then 6.90 divided by 2K is 3.45 milliamps. 3.45 milliamps. And then you say to yourself, I'm done. Because what's the voltage here? The voltage here we got down here. It's 38 volts, and this is the current. What is the voltages here and here? Well, we got that here and here. So this voltage is 1813 with this current, and this voltage is 12.95 with this current. And then last but not least, you got the voltage and current there. And then you're done. Have a nice day.